Kia ora. What do you need to know for the 91391 exam? So, first you are told under the specifications, it'll talk about constitutional isomers rather than structural isomers, but it means the same thing. You need to be able to name primary amines using IUPAC, but not secondary. And you won't need to know the common names of amino acids like glycine or serine, but you may be able to be asked for the IUPAC name for them. And you would be expected to know your level 2 chemistry. So don't forget that, although these two modules have covered most of the level 2 chemistry as well. You need to know your functional groups. So here are the ones you need to know off by heart. The ones in blue you covered last year at level 2. So hopefully those will be familiar and there are therefore not too much extra to learn. Very important that you can identify functional groups. If you're given the structure, you can know what the functional group is, or given the name, you'd be able to say what the structure is. So the structure, functional groups, really important, and isomers. So learn your definitions. What is a geometric isomer? What is an optical isomer? And so on. Know how to draw molecules. So you can do it in the semi-structural way, but make sure that your bonds are between the bonding atoms. So this line here is not between the N and the H or to the H, it's the N bonded to the carbon. I really recommend you use the full structural formula like this, because that way you can quickly see oxygen has only got 2 bonds, carbon has got 4 bonds, nitrogen has got 3 bonds, and hydrogen has only got 1 bond. It's quite a common error for students not to draw the right number of bonds, and therefore it's wrong. So stereoisomerism, geometric and optical isomers or enantiomers. So geometric you came across last year, the trans and the cis. Please note that each carbon of the double bond must have 2 different groups on it. Very important point to remember. If this was a methyl as well as that, you couldn't get geometric isomerism. Optical isomers, a carbon atom in the molecule, don't say central atom because it doesn't have to be central, it just has to be a carbon atom that has 4 different groups on it to call it chiral. So by group, I don't mean functional group, I just mean a group of atoms. So methyl group, hydroxide group, ethyl group, and it could just be a single atom like hydrogen or chlorine and so on. So to draw it, you can use this method where it's quite easy to draw because they're all 90 degrees, but you get the 3D aspect by using solid wedges coming out of the page and hashed wedges going into the page. Remember the thick end here, the thin end of the wedge by the carbon. And to get the mirror image, you just simply swap any pair. So here I've swapped the hydrogen and the hydroxide, or you could use this format to draw, whatever is easiest for you. Physical properties to distinguish between the organic compounds, solubility and melting point. So everything you learned about polarity, what is a polar molecule, intermolecular forces, hydrogen bonding is very helpful here. But please remember that those hydrogen bonding rules and so on only apply to the short chain molecules. So butanol, the alcohol can hydrogen bond with the water, so it's still soluble, but pentanol, that alkyl part, those 5 carbons, is just simply too nonpolar to really dissolve in water. Now, the rotation of plain polarized light is the only way we can distinguish between isomers. So if asked how you could distinguish them, don't say they are mirror images. You can't see the molecules, they're too tiny. So the only way you can do it is by putting a sample of the substance into a polarimeter and measuring how it rotates the plain polarized light. Reactions, lots of them. So start learning. Learn them by type, so substitution, elimination, and so on. Reactant, in other words, alkene, what will an alkene react with to form something? Reagent, so these are the reagents here, okay? And the product, so in other words, how do I form an alkene? How do I form an alcohol? So learn those in those 4 different ways. The oxidation reactions tend to be used more for identification, although these 2 can also appear in reaction schemes. So for identification, know that your purple permanganate becomes the colorless Mn2+, or the orange dichromate becomes the green Cr3+. You should know those from your redox chemistry. And then these are all for the identification of aldehydes, where the aldehyde gets oxidized to the carboxylic acid, and here for the toluenes, the Ag plus in ammonia, the Ag plus is reduced to a silver mirror. Here the copper 2 plus is reduced to the brick red copper 1 plus, and the same thing for the Benedicts. So those have the same sort of color changes. And reduction, aldehydes and ketones going back to alcohols, so that's fairly easy to remember with sodium borohydride. Elimination, harsh conditions needed to push that elimination. So it's normally alcoholic or concentrated, and hopefully that'll be a tip to help you remember. You need to know the major and minor products for the elimination of alcohols and haloalkanes. So it's Zaitsev or Zaitsev. He's a Russian chemist, different alphabet, so there's different spellings to his name. The mnemonic is the poor gets poorer, but please learn this definition for the exam. So what do I mean by reaction site? This pink carbon is a reaction site because it's got the OH or the Cl or the Br. So the red carbon and the blue carbon are adjacent. So the blue carbon's got fewer hydrogens, so a blue hydrogen will be lost for the major product, and a red hydrogen will be lost for the minor product. Polymerisation is where you look for an amine to react with a carboxylic acid to form a peptide link, or it could be an alcohol with a carboxylic acid to form the ester link. So when you want to undergo hydrolysis and they break it up, then you look for that peptide or ester link and draw a line between them. Hydrolysis means you're adding on water, H2O. So OH goes to the carbonyl and H goes to the amine. So OH there, H there, and you break that bond in the middle. But why these extra hydrogens? Well, under acidic conditions, the basic amine in both cases will react with the extra hydronium, and so they'll be added on to protonate them. But under basic conditions, you don't have extra hydronium, you've got extra hydroxide, so it's the H that gets removed from the COOH acidic part. So you form the carboxylate salt. Then finally, the addition reaction is used of an alkene for the identification. So it's the decolorization of bromine water from a sort of orangey brown to colorless. Very quick in alkenes, but please note this reaction also works with any, well, pretty much any organic compound. So alkanes, amines, alcohols, it's just they're much slower. So the important thing is that it's a quick decolorization. This happens in a few minutes. So all the best. Kia ora.